I don't know, but 82, they had a thing on the news this morning. 82% of the time, there's 6 more weeks of winter. 18% of the time, there's not 6 more weeks of winter. Thank you. But the funny part is, they're like, 6 more weeks puts us to March 21st, our equinox anyway. So that's 6 more weeks of winter. So 82% of the time,
it's just a weird tradition.
It is. It is. It is. It has to be sunrise, doesn't it?
It's not updated 7:59.
Oh wow.
But I don't think he came out of his little house yet.
He didn't come out yet. Good for him. He's like you guys. Doesn't want to have to get up any earlier.
No, he saw his shadow. No, he did. Look, you look at your house. He saw his shadow.
6 more weeks of winter.
Oh, she's just watching it run.
Okay, so let's go through these guys. And again, your test is going to look just like this. I give you the basic parts, and then I give you the application parts. So if we're looking for an x value to be less than 170, you start with your graph, you set up your pieces. I want the standard deviation on the bottom, the z-score on the bottom. I want the x values on the top. I need shading and sketching. If I don't get a probability statement and shading and sketching, I'm not going to grade the problem. If you use the calculator, I still need a sketch, I still need a probability statement. And then you can say to me, calculator. You can bypass this piece right here if you use your calculator. If you use your calculator, put in what you put for your calculator step. Put your mean, put your standard deviation. What happens is this, you get an answer back. If you messed one of those things up, and your answer is wrong, that's all I can grade you on, is a wrong answer. If you showed me what you put in, I can put it in too and see where you went wrong. Okay, so remember, if we're looking for the cutoff of 170, judge this. This is to the left. I'm shading to the left. If halfway mark is 50%, I am less than 50%. I expect my area to be less than 50%. I expect my z-score to be negative because it sits on the left-hand side of this curve. Make sure you check those things. I can't tell you how many times kids give me a negative z-score and then this 80%, God bless you, 80% of the area. I'm like, how is this possible? They don't match up. When you're here, greater than 182, that is to the right. And most times if I give you like an ABC, one sketch is all I need. Just give me a little cutoff, I'll figure out the rest. Where do shade? So one sketch is all I need. To the right, I know this also is less than 50%. But now, and my z-score should be positive, but when I look this up, this is greater than 50% because we always find the area to the left. So I know I have to subtract it from 1. It's got to be smaller than 50%. So that's kind of like your heads up. Hey, remember, subtract from 1. If you have any questions, stop me. You have to know this z-score formula. But again, what helps you is this. You're only given 2 pieces of information. You're given the mean, you're given a standard deviation. When we give you an x value, the x value has to be close by the mean, doesn't it? So if I want it, so for 170, if I know that it's going to be a negative z-score, I'm going to subtract the smaller minus the larger, x minus the mean. If I'm 182 and I know it's got to be positive, I'm subtracting the larger minus the smaller, x minus the mean. So it does fit your graph. Make sure you make it make sense. I say this 100 times, and then when I'm grading the test, I'm like, does this match yours? Could it possibly be negative? And you'll say, what? I don't understand. And I say it 100 times. Okay. Again, I know these problems were a little bit long, but the good part about this was it kind of overlapped. If you found your z-score once, you didn't obviously have to find it again. So you don't have to do that part over. I just did it because I separated it in case you wanted to see them. One sketch, that's all I need. Less than 66, my answer is going to have to be a negative z-score. I look up my area. It is my area to my left. Notice the calculator and the table give you a slightly different answer. Slightly different because of this. I had to round the z-score to 2 decimal places for me to look it up in the table. The calculator does no rounding. It carries on indefinitely, so it gives us a more exact answer. So I need to know when you use your calculator, when you use your table. And in between, and if you put this in your calculator, let's throw this one in. For those of you that like your calculator, or even just want to do it a little bit better, go to your normal CDF. The in-betweens are so nice. From 66 to 72. Sometimes you don't like the lower limit with the negative 999, the positive limit with the positive 999. So do just the in-betweens in here. 62 to 72. When you use an X value, you have to put the mean and the standard deviation in. When you use a z-score, you don't. You put in the 0 and the 1. So I put this information in, I paste, and it bypasses all of this. It bypasses all of this and cuts me right to my answer. And see, your answer is slightly more exact because we didn't have to round your z-scores. The calculator takes care of that. So if you're going to do this on a test, you're going to give me this probability statement, and you're going to say calculator, and just put what you put in there. Lower, just say lower was 66, upper was 72, and then just your mean and your thing, and just give me your answer. You bypass that whole piece. Like I said, I usually get like half the kids like the calculator and half use the formulas. I think a lot of kids don't like the calculators because of the lower limit, and it kind of throws them off a little bit. So use it just for the in-between. It works really nicely. Greater than 72, I can tell by here that my z-score has to be positive. I can also tell that my area is less than 50%. So when I come down here and my area is bigger than 50%, it says subtract from 1. And you can leave your answers with the decimal point. Well, I like to look at the percent when we talk about it because it makes more sense when we say, if you choose a person at random, what is the probability that their height is more than 72 inches? So the probability that the person I choose at random is greater than 72 inches is about 18%. I have an 18% probability that that person is going to be greater than 72 inches based on this information. Okay, it doesn't make sense when we say 0.1841, but you can leave your answers like this. ACTs, like I said before, ACTs are a little bit different than the SATs. SATs almost fit the normal curve. ACTs, they use a normal curve, but they're a little bit better because you figure ACTs, not everybody takes an ACT. You only take it if you know you're going to do well on it. You know, you only take the ACT when you say, oh, I just need a little boost on my SAT. I'm really good at my physics, so I'm going to take the ACT for physics. So ACT doesn't necessarily follow a normal curve, but we use the normal curve to look at it. So they're telling us that it's normally distributed, really that it's not, but as long as they tell us it's normally distributed, that's what we do. We find the mean, we find the standard deviation. Set up your chart, find your probability that x is less than 16. Now be careful, remember we use x when we have a value, we use z when we have a z-score. Okay. And between this and greater than 26. Again, use your judgment. Do I expect less than 50, more than 50? What do I expect? You want to know that you're in the ballpark. Any questions on this? I know these are redundant, but I want you to get used to seeing them. Do the graph, do the probability statements, do the work. How many of you actually use your calculator? Yeah? Okay. Couple? And try them. If you want to try them, take out your calc, try them. Wow, that fell right into my normally distributed. Look at that. So again, we have a stair climber, normally distributed with a mean of 20 minutes, a standard deviation of 5 minutes. Find the probability that a randomly selected athlete uses his stair climber for less than 17 minutes, between 20 and 28, and more than 30. Okay. And of all of these, which one is the unusual one? Anybody remember the unusual cutoff? C, because it's less than 5%. This is a pretty good one right here. Between. That between one is close to like a big chunk of it. It's close to 50%. This one is unusually small. Anything less than 5% or greater than 95%, unusually small or the opposite. Okay. Do you have any questions? Everybody got this? All right. Okay, here's an SAT one. They gave us a picture. They wanted to know between 200 and 450. So there's a big chunk of your score there. There's a big chunk of this. If I look at this, remember, somewhere in between here, I'm saying it's less than 50, right? It's got to be way less than 50 because I'm still to the right of to the left of this. So it's got to be less than 50 and probably less than 40 because I didn't use this piece over here. So I find my z-score for 200, I find my z-score for 450, and I subtract my area, not my z-scores, remember that. And again, this one's a great one to put on your calculator. All the pieces are right there. So I go to my calculator, I go down to the second one, it's a normal curve, I'm accumulating my area, and I say lower is 200, upper is 450, take a look at the probability statement. My mean is 488, and my standard deviation is 114. And I paste. Okay. And I round to this. And remember, your rounding on the calculator is exact because it doesn't have to round your z-score. When we look up your z-score, we have to round it to look at the table. Your z-score can only be 2 decimal positions. Your areas are 4 decimal positions. Your calculator has a different rounding. The round's a little bit more exact. Alrighty.
Again, on a second calculator.
Uh-huh. So then they took this and they said, what percentage are less than 600? I think it used the same thing. So it said use the same information, less than 600. I'm up over here somewhere. Less than 600 is going to be more than 50%, right? So my z-score is going to be positive. I plug it in. I find my percentages. I find my percentages. And then here's the part that we did yesterday too. Out of 1,000 randomly selected SAT scores, how many would you expect to be greater than 500? First thing you have to do is find the probability that they are greater than 500. Then take that area, that probability, remember under your curve to the right, you're going to subtract from 1. Find your z-score, find your probability, and then multiply that by 1,000. And round to whole numbers. You count people discretely, with discrete numbers. Whole numbers. Again, it's a little bit to the right. Here's your 500. I want the area to the right. It's going to be less than 50%. Your mean is 488, so you're slightly to the right. So you're slightly less than 50%. Oh, you're slightly greater than 50%. Nope, you're slightly less than 50%. I'm sorry, something happened in my thing where it slid over. I have 2 versions of Word, one when I write in and one that's here on this computer, so sometimes it slides my work on top of the next one. Are we okay with that? Remember how to do the, if I give you an n, if I give you a number or something, then you just multiply it. 15, again, gave you a chart. Asked you what, same type of information, again, in between, greater than, less than. You good? I'll just go through these answers. Anybody struggling doing this? I know it's a little bit long. This was a little redundant in the work, but I thought if I gave you enough of them, you get used to a pattern. You're always going to give me a probability statement, which they gave you the probability statement for the first one. You're always going to give me a probability. Don't forget it's the x in between, not the z. You're going to hit some of these. And then they did the same thing with these guys. And then they said, how many would you expect out of 250? So once you find your probability, multiply it by 250. All right. What? Okay, these are real basic, and this is exactly how your test is starting out. The first three are going to look just like these. All I want you to do is a basic sketch for me. So all I want is this. Give me the sketch. This looks like your quiz did. So I'd like to start you off on the easy side. So it says find the area to the left of a z-score of 0.33. Between what two whole numbers do I find 0.33? 0 and 1. 0 and 1. I'm not a stickler on, are you closer to the 0 or you're closer to the 1? This is a sketch. So anywhere that you get between 0 and 1, I'm good. Which way am I shading? To the left. So I want the probability that my z-score is less than 0.33. I want a probability statement. This is the z, not the x. I don't have an x here, just a z. I look it up in my chart, and I get 0.6293. Did I expect it to be greater than 50%? Yes. So I'm saying, good. I think I got that one right. Okay. I go to the next one. I do another sketch. 0, 1, 2, 3. Remember, we exaggerate our sketches. Okay. Where do I find a z-score of negative 0.57 between which two integers? 0 and negative 1. Which way do I shade? To the right. Okay, so the probability that z is greater than 0.57. Only a z-score. Do I expect this answer to be greater than 50% or less than 50%? Greater. But when I look up this z-score tells me 0.28, oops, sorry, tells me 2843? 2843. Oh, wait, that's right. It's just moved over. And I say, wait a second, I thought this was going to be greater than 50%. So what do I have to do? Subtract it from 1, because that is this little piece over here, to the left. Every time I look up area in my table, it's to the left. So I subtract it from 1, and I get 0.7157. Leave your answers just like that. The third one, have an in-between situation. Again, just give me your z-scores. I want between negative 1.55 here and 1.04 here. That's quite a big chunk, doesn't it? Plus or minus 1 is 68%. So estimate this for me. If plus or minus 1 right in here is 68%, what percent do you think is going to fall between those? 70-something, 80-something. It's going to be more than 68%, right? So it gives me a ballpark. So now I want the probability that my z less than negative 1.55, 1.04. I look up the areas and I subtract the larger area minus the smaller area. And I get 0.7902. And we said it was going to be in the 70s, low 80s, because it had to be bigger than 68%. Plus or minus 1 is my 68%. Remember, plus or minus 1 is about 68%. Plus or minus 2 is about 95%. And plus or minus 3 is 99.7%. So it kind of gives you a little bit of a feeling for what you're looking at in your curve. That's why this area is half of a 0.3%. Half of a 0.3. We just make it look a little bit bigger because we need to space these things out. Can everybody do those? Your first 3 in your test are going to look just like that. Just like that. Very basic. Then we're going to have 2 problems, and your 2 problems are going to look basically like number 33. If I could move this down. It's going to look just like this. So, kind of look at number 33. They're going to look like the ones that you just been working on. In a study of migrating sandhill cranes, the distances traveled in a day are normally distributed. I need to know this. I can make a curve now. Here's my sketch. Okay, they're normally distributed with a mean of 267 and a standard deviation of 86. These are the only 2 pieces of information that they're going to give to me. Pull them out. You need that mean, you need that standard deviation. Start with your mean in the middle. And what do I do to move up here? What do I do to go to the next one? Good. You keep adding 86. So this becomes 353. This becomes 439. And this becomes 525. I have a better view of what's happening once I put all my x's there. And I subtract 86. Because remember, as I read from left to right, they should increase. So going the opposite way, I'm subtracting 181, 95, and 9. Okay, so I have a good view of what's happening here. So now I'm looking for the probability that x is less than 200. This is an x value, not a z value. Make sure it says probability x less than 200. So I look at my chart, and you only have to make one. You can kind of squeeze them all into one. I find 200, somewhere between the 181 and the 267, right? I draw a line somewhere, and which way do I shade? Left. Is that area going to be less than 50% or more than 50%? Less than. Is that z-score going to be positive or negative? Negative. So when I use my z-score formula, I need to subtract the smaller minus the larger. X minus the mean. And I need to make sure I find the z-score somewhere between 0 and negative 1. And sure enough, my z-score comes out to be negative 0.78. Am I done?
No.
Nope. What do I do now?
I'm area.
I find the area. I look up on my table. Remember, z-score positions round to 2 decimals. Because all your table gives you is to 2 decimals. And I get 0.2177. And you can leave it just like that. Just give me the 4 positions. If you do it on your calculator, give me 4 decimal positions for your area. If you do it on your calculator, you can do it z-score wise, you can do it with the x. I always feel like if you're gonna do it, you might as well just do it with the x in it. Oops. So my lower limit, because I'm coming from the left, make it negative 999. My upper limit, that's where I'm going to stop at my 200. My mean, 267. And my standard deviation, and paste. And I should get my area. Again, round this to 4 decimals, so that's going to be 0.2180. Remember, your calc is a little bit different. You're still going to give me your sketch, you're still going to give me your probability statement, but let me know that you used your calculator. Find a probability that is between, so the x is between these two numbers. Less than, make sure you give me less than. So for 250, I'm here, and for 350, I'm here. Do you think that's going to be less than 50% or more than 50%? Or about, but maybe a little less. Plus or minus 1 gives me 68%. So I'm going to be smaller than 68, right? At least I get a ballpark. Again, you're going to get your z-squared for this guy. This guy's going to be negative. You're going to get your z-squared for this guy. This guy's going to be positive. And they should come out that way. If they don't match your sketch, then you did something wrong. This z-squared is going to be negative 0.20. This z-squared is going to be 0.97. You're going to find your areas, and you're going to subtract. And yeah, we said that had to be less than 68%. You probably figured a little less than 50%. Some of you guys said less than 50. That was a good guess. But put yourself in the ballpark. If the last one is greater than 500, 500's over here, give me an estimate on what percent you think it might be. 13%, 10%, 8%, somewhere little, right? So when I find my z-score for this guy, it should be positive. I find my z-score to be 2.71, very, very close to the 3. And I look at my area, and it's very, very large. So I know I subtracted from 1. And look how small my area was. It was less than 1%. Okay. And these are what I'm going to be asking you tomorrow. I might even throw in, if the next 1,000 people walked in, what is the probability that they are greater than 500? And then you would take that probability and multiply it by 1,000. Probabilities we use for forecasting, for trend setting, for predictions, for inferences. We use